Okay, so our second part is focusing on distinguishing the difference between the definition of perpendicular lines and theorems 2.4, 2.5, and 2.6, and then any other theorems could be applied here. So we have a diagram here. It says use the provided diagram to complete the table. I have a given statement. There's a conclusion that's been made. You just have to give the justification. So is the justification the definition of perpendicular lines? Is it theorem 2.4? Is it theorem 2.5? Is it theorem 2.6? Is it angle addition postulate, segment addition postulate, definitions of anything we've learned before, supplementary angles, complementary angles, or is it the vertical angle theorem? So anything we've used. So that's what we're working on right now. So what is given? Given was the fact that AB is perpendicular to BC. So we know AB is perpendicular to BC. That's what was given. We're concluding then that angle ABC is a right angle. Well, I knew that as soon as they said that. I made that mark before I even read the conclusion. But why? What is the justification? So look at what was given. What was given is that two angles were perpendicular to each other. What was concluded is that we have a right angle. So let's look at the definition. What is given? Given is that lines are perpendicular to each other. What is concluded is that they intersect to form right angles. Okay, that looks like it could be the definition of perpendicular lines. Let's just check these 2.4 and 2.5. 2.4 says if two lines are perpendicular, so that's also given that two lines are perpendicular. What the conclusion is, though, is that they form congruent adjacent angles. That would be angle 1 is congruent to angle 2. That's the conclusion here. If I look at my statement, what was concluded? Was it concluded that one angle is congruent to another? No, it was concluded that we have a right angle, which is what the definition says. If two lines are perpendicular, then they intersect to form a right angle. And that is what was given. Two lines are perpendicular. What is concluded is that we have a right angle. So what is the justification? It's the definition of perpendicular lines. That's why we know this to be true, given two lines are perpendicular. Okay, let's look at number 2. Let's erase this. Number 2, it says BD is perpendicular to AC. Okay. And then what's concluded is that angle 3 is congruent to angle 4. Oh, well, what did I just do down here? I said if two lines are given that are perpendicular, right, this is the given, that some line L is perpendicular to some line M, L, M. Then what do we conclude? We conclude that they form congruent adjacent angles. We conclude that 1 is congruent to 2, or 1 is congruent to 4, or 4 is congruent to 3. Is that what was concluded here? Yes. We have two adjacent angles, 3 and 4, that they are congruent to each other. So this, to me, is theorem 2.4. You can write theorem 2.4, or you can write out perpendicular implies congruent theorem. So perpendicular implies congruent theorem. Look at those symbols. Perpendicular, remember the arrow means implies, congruent theorem. Same. You can write either one of these things on the paper. Okay, once again, the next one, let's erase from our diagram. It says that we have given, once again, what's given is that two lines or line segments are perpendicular to each other. So DC is perpendicular to DA. Okay? Well, then it says we're concluding that angle 7 and angle 8 are complementary. Well, what do you notice about angle 7 and angle 8? What do you notice about angle 7 and angle 8? They are adjacent acute angles. Adjacent acute angles. And if they're adjacent acute angles, hopefully you're thinking of this one, the split complements theorem, which said what? It says if the exterior exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. Well, I told you that their sides are perpendicular, therefore the two angles are complementary. Okay, so that is my split complements theorem. Theorem 2.6, or the split complements theorem. Same. Okay, let's look at the next one. Angle 7 and angle 8 are complementary. Okay, so it says angle 7 and angle 8 are complementary. So what do we conclude? Therefore, we conclude they add up to 90 degrees. Okay, so why is that true? If angle 7 and angle 8 are complementary, instantly in your brain you should think, oh yeah, that means the sum of them is 90 degrees. Why? What allows you to think that? What is the justification for that statement? Why can you conclude that the measure of angle 7 plus the measure of angle 8 equals 90 degrees based on the fact that they're complementary? It's the definition. The definition of what? The definition of complementary angles. Right? We went over the definition of complementary angles. We said two angles that add up to give us 90 degrees. So if they're complementary, they must add up to give you 90 degrees. If they add up to give you 90 degrees, they must be complementary, because all definitions are biconditional. Okay, let's look at number 6. Angle 6 is congruent to angle 4. So angle 6 is congruent to angle 4. Therefore, we're concluding that two lines are perpendicular to each other. So this is the if statement. This is the then statement. So if two angles are congruent to each other, then the lines are perpendicular. So where do we have something that concludes lines are perpendicular? Here, then angles complementary. Well, it's not 2.6. Let's look at 2.5. Then they are perpendicular. Here it is. Let's see if it has the given. If two lines form congruent adjacent angles. So yeah, this one says if the measure of angle 1 is congruent to the measure of angle 2, if angle 1 is congruent to angle 2, then the two lines are perpendicular to each other. Then L is perpendicular to M. That's what that says. This is the if statement, the hypothesis. This is the conclusion here. So which one is it? It's theorem 2.5. What do we start with? We started with the angles being congruent to each other. We concluded that therefore those are perpendicular lines. So that is theorem 2.5, which is congruent implies perpendicular theorem. Right? That's congruent implies perpendicular theorem. Okay, let's look at number 6. Number 6 says that angle 4 and angle 5 are vertical angles. So angle 4 and angle 5 are vertical angles. Well, therefore they are congruent to each other. Well, if two angles are vertical, then of course they're congruent, because when did we learn that? We learned that because that's the vertical angle theorem. We just learned that last class. The vertical angle theorem says that if two angles are vertical angles, then they must be congruent to each other. So number 7 is our final one. It says angle ADC is a right angle. So angle ADC is a right angle. Therefore, so this is the if statement. If angle ADC is a right angle, then the measure of angle ADC equals 90 degrees. Well, yeah, anytime I tell you an angle is a right angle, what immediately comes to mind? Hopefully you're saying, well, therefore it's 90 degrees. Why is that? Why does your brain do that? Is there a theorem that told us every right angle is 90 degrees? No, it's not a theorem, it's the definition. The definition of what? The definition of what a right angle is. A right angle is a 90-degree angle. A 90-degree angle is a right angle. So as I've said before, definitions are biconditional. So before you finish, I would go back, I would review You know the difference between definition of perpendicular lines, Theorem 2.4, Theorem 2.6, Theorem 2.5. These are all the ones that are about perpendicular lines. Notice the difference about what is given. When perpendicular lines are given, you have these three options as your conclusions. If you have perpendicular lines given and you conclude that we have a right angle, that's because of the definition. If you have perpendicular lines that are given, but you conclude something about 7 and 8 or adjacent angles are complementary or they add up to 90 degrees, that's the split complements theorem or Theorem 2.6. If perpendicular lines are given and you have two angles that are congruent to each other, that's Theorem 2.4. Perpendicular implies congruence theorem. So pay attention to what is given and what's concluded, and look at those theorems and those postulates and those definitions, change them into if-then statements if it helps, and see what is given, the if part, the hypothesis, and what is concluded. Okay, good luck. Please see your teachers if you have questions. Come see any of us during our help sessions. We're happy to explain these things more clearly or more thoroughly. Yeah, make sure you're getting your questions answered sooner rather than later. All right, good luck.